don't mind. I'm very excited to introduce Dr. Checo Colón Gaud as our seminar speaker today. We met at an AFS or American Fishery Society meeting at a student mentor lunch, and since then, Checo has gone above and beyond to mentor me as I navigate academia and future opportunities. So I'm very appreciative to have him here. So I'd like to say a big thank you for that. Checo is a professor of biology and the associate dean of the Jack N. Everett College of Graduate Studies at Georgia Southern University. He earned his bachelor's degree in biology from the University of Texas, El Paso, and master's degree in fisheries from Louisiana State University, and a PhD in zoology from Southern Illinois University. Checo's research addresses the role of aquatic consumers in organic matter processing and their influence on ecosystem functioning. His research is directed towards understanding the ecology of freshwater systems, particularly focusing on food web structure, organic matter dynamics. And most of his research, his recent research and ongoing work has focused on tropical headwater streams, which is of particular interest from his Puerto Rican background, and wetlands in the southeastern U.S. He has brought in around $5 million in grants from NSF, or National Science Foundation, to broaden participation and leadership in natural resources science with an emphasis on aquatic ecosystems. His work stems over 10 years with the Society for Freshwater Science as part of their NSTARS mentoring program. Through NSTARS, he and others at Georgia Southern have extended mentoring opportunities to over 150 undergraduates, over 50 graduate students. Checo has mentored 22 graduate students, greater than 50 undergraduates, and all the while being able to co-author 130 co-authored peer-reviewed publications with his students and colleagues. Outside of his academic work, he serves on the advisory boards of the Georgia Adopt a Stream program and for the Ogeechee-Peninsula Riverkeeper. He is an all-around great person, and I'm very happy he's with us today. So please join me in welcoming Checo.
That's cool. That's a lot of stuff. I really appreciate the opportunity for being here. I am going to try to do something I think relatively different, because I'm going to try to give 2 talks here and just kind of pack them into one, and maybe a little different in terms of a typical research seminar. I am going to talk about research, but then I'm going to flip the script a little bit to talk about opportunities that are important to me and where a second probably lifetime of my academic career is going to now. So to do that very quick, raise your hand if you're a student. All right. Keep your hand up if you're an undergraduate student. Cool. This talk is for you 2 guys. No. And again, and with that in mind, obviously, to try to incorporate the role of us as faculty in mentoring. Mentoring, as Aaron mentioned, is how we met, and probably the most fulfilling part of me, at least as an academic career, and hopefully for all academics out there. So, and as I say that, I think just maybe a week or days before coming out here, I got an email from one of your faculty that I got to work with when she was an undergrad. So think about how, connecting the dots and inspiring in terms of like the things that you get to see from an academic standpoint. So thank you for having me here. As you can tell, I am chatty. So hopefully me trying to give 2 talks doesn't mean that we're here till 2 o'clock. I'm going to really just keep my eyes on you. And if you're falling asleep, I'll, advance like 10 slides at a time.
I'll bring out the hook.
That's right. Yeah. Yeah. But as Aaron mentioned, I am at Georgia Southern University. My contact information, even as I'm trying to get into the world, like, you can even contact me to things like, actually, X now, not even Twitter. So again, if there's anything that you see out here that is exciting, I'm easy to find, please feel free to contact me. Feel free to continue the conversation. So very quickly, I am a buggy person, meaning that a picture like this really defines a regular day in my research history and my research lab, is that I am primarily hooked on diversity. In fact, yeah, I'll say it that way. I was hooked on diversity as an undergraduate student, primarily by thinking about benthic invertebrates, benthic macroinvertebrates, and aquatic insects particularly. So a picture like this, even though, I mean, when I show this in class, initially in a general biology class, my students might be like, I don't know that I want to do that. If I show it to my wife and kids, they definitely don't want to do that. But if I see this, this tells me a lot and gets me excited about the type of ecosystems that I work with. Not only is there a lot of different taxonomic diversity there, right? But as you kind of get into understanding the life histories and the roles and the things that these organisms do, there's a lot of information that you can gain about an ecosystem, whether it's about their habitat diversity, because some of these organisms need to be successful in a particular habitat, whether it's about their functional diversity or what role they play in the ecosystem. So that's that FFG% out there typically tells you about their functional feeding groups and how they feed and how that feeding might relate to the role in ecosystems. If you're into health and condition of ecosystems, you can tell that some of these organisms are either sensitive to particular conditions in your system, whereas some of them might be very, very tolerant. So you can learn about the quality of your ecosystems, your habitats. But more importantly, you can really use this to paint a picture as to what might be happening in your system at a given point in time and in real time, because they're experiencing those conditions. So that's hopefully my pitch for not just diversity, but the type of work that I like to do with aquatic invertebrates. And this will be the poster child or the poster children of the type of work that I'm doing. Now, primarily, I like to study not just their life history, but really their role in ecosystem functioning, particularly as it pertains to how they feed and how they provide food or energy to other consumers. So I like to show this picture from the work of a good colleague, Colón Baxter, from the early 2000s, where it illustrates not just how really tangled food webs can be, but where do I place aquatic invertebrates in those food webs and their roles to really understand what might be happening in an ecosystem. Aquatic invertebrates are not only somewhere at the middle point, right? They're kind of middle consumers that become conduits of energy, obviously, to the organisms that we're very interested in, like larger macro consumers like fish, amphibians, so on and so on. But we could tell that they're really playing a role in transferring or translating basal resources like primary producers like algae, and even the detritus pathways like leaf decomposition, in transforming that energy into energy that's going to go quickly to higher consumers, to higher trophic levels like fish and so on. Now, the good news is that because of their intricate life histories and how just complicated that might be, those that are not getting eaten, particularly insects, might emerge into terrestrial systems as they are adult and really become a linkage between aquatic and terrestrial ecosystems. So that's exciting because now we're taking our ecosystems outside of the bubble of just thinking, oh, I'm doing aquatic stuff, but really understand how much influence they might have in terrestrial areas. Because those that emerge as aerial adults might be the food for things like spiders, bats, birds, lizards, so on and so on. They may also return to the ecosystem, not just to deposit energy-rich eggs, but also as prey or as detritus or carcasses or so that also become important. So this is why I like aquatic inverts as a poster organism for the type of work that we do. Now, for the most part, my work has really involved what organisms or what compartments might play in ecosystem processes. And arguably the best way to know that, if you want to know what something does in an ecosystem, well, you can take it out and see how everything else responds. So early in my career, I was fortunate enough to have not just nature, but humans and our needs really play natural experiments on us, where we can understand what happens if you take a consumer compartment and how my organisms respond to that, how things might change. But likewise, even if you take just a habitat compartment or a resource compartment and try to understand the response by using invertebrates to how your ecosystem might shift, change, or in extreme cases, potentially collapse. So I'll give just a few examples of this, just mainly as playing a highlight of the type of work that I like to do. And when you come to seminars like this, I think about it as an opportunity to perhaps interest students and recruit. So if you see anything out here that is of your liking and you're a student, yes, always looking for great students to join our labs and our programs. And likewise, if you're faculty, if you have money and want to collaborate, that's always good. Okay. That's supposed to be good, no funny story. All right, so I'll give you a couple of examples. And the caveat here is that I want us to completely ignore the numbers. In this first part of my talk, I just want us to look at things that are just connections, not necessarily worry too much about data. And that's my way of pitching that I'm not going to show you a lot of data. But the first example comes from work that I did in the tropics in Central America and Panama, where we were, I don't want to say fortunate enough, but we were in a place where we were able to document a predictable move on amphibian declines that was occurring at a pace where you knew where amphibians were going to decline next, more or less. So this is happening around, I'm in the timeline here between the early 2000s, where you had a disease-driven amphibian decline that was decimating populations, communities, let's just say, of stream-dwelling endurance, of stream-related amphibians, predictably moving them out of the system where we had a chance to see systems without amphibians and systems with amphibians that later lost amphibians. And I'm saying a lot about amphibians, so you can think about it this way. Let's paint this picture. A lot of pretty frogs and pretty frog diversity in the tropics. Incredible amounts of diversity. This picture doesn't really do it a lot of justice. It's just four taxa here. But you can tell, I mean, these are charismatic, not just in terms of their colors or views, how they look. I mean, we see them now if you go to an aquarium or a museum, but also in terms of their sound, right? Like the noise that they make, like all the things that attracts us to, and people that might be into frogging or herping into watching amphibians. Sadly, all these organisms were present when I started doing work at this site, and unfortunately, they're not there anymore. So these are things that you now have to go to an aquarium or a museum or sort of see them, but not in their original native habitat. Well, and that's not necessarily just to paint a dim picture in terms of diversity and our interest in diversity, but also in terms of the roles that they play. If you think about a common or a traditional tropical stream, this is a stream that we work with in Panama. In riparian areas, you have frogs that are playing an important role, right? They are feeding on emerging insects. They are a connection or conduit between the aquatic system, as aquatic prey might come out of the system, right? And then become food in terrestrial riparian areas. They're also prey to larger vertebrates, right? So a lot of snakes, and I paint a picture here of a snake, but you have birds and other animals that might also feed on amphibians that live in the riparian zone. So important source of food themselves or energy themselves. Those of them that don't get eaten might return to the system and deposit energy-rich eggs that now become a transfer of energy from the terrestrial zone back into the aquatic system. And in the aquatic system, many of us know, right, as tadpoles, they could play an important role as top-down control, right, as important grazers or herbivores that are keeping algae in check. And again, I say algae here, although this is a very heavily forested stream, so limited light penetration, so the amount of algal production out there might be relatively limited. So this is an important component of this ecosystem, not just linking terrestrial to aquatic, but then the job that they do in the aquatic system as it matures, right? These are kind of like the cattle or our bulldozers of the systems, not only keeping top-down control and algae in check, but also through bioturbation, like minimizing the amount of sediment accrual that you might see in the systems. I'll give you a little bit more. Here's an underwater picture from one of our sites. Prior to declines, you could tell all the tadpoles that are in there. Can you? No? Okay, here we go. And I'm probably missing a bunch in there. So the neat thing about this, right? Like you see all these rocks, all those tadpoles, not just in the rocks, but also in the lip litter, right? Like decomposing organic matter, but they're out there just constantly scraping and shredding, and well, not shredding, but just mainly scraping and grazing on algae, which is the reason why you see in this rock some of this greener patchery. I feel bad because the folks in Zoom don't see my finger pointing, but maybe it'll work like this. But they are really maintaining that ecosystem the way that it looks, right? And arguably you could just trust me just saying that, or you could just see the difference in terms of a system. And this is in the same place with tapples. This is a different angle of the picture you saw before, right? And after tapples, same fish. But the idea is, right? I mean, visually for me, you could tell this, okay, this is two different ecosystems in terms of the resource base. And partly because now you lose that top-down control on algae, but also the amount of sediment that accrues as now that algae goes unconsumed and senesces, right? So it starts to decompose itself. And now you've changed the resource base. So my role when I became part of this project was to try to understand how those other consumers that depend on that resource might respond to the change in the resource base from losing a primary consumer or a main role consumer. Although it is a primary consumer, right? This is the primary production. So, and the way that I did this was really to try to understand not just things like abundances and biomass, but the energy transfer or the flow of energy used in food webs between that consumer and the resource base with tapples and without tapples. So here's a little bit of data. I told you I was interested in food webs. I don't want you to worry about the numbers. I mainly want you to worry about the fact that I have consumers at the top, right? Resources in the bottom. And then this arrows based on the width of the arrow is really representing the amount of energy that is transferred from the resource to the consumer base. I am isolating out of this food web, only showing you some of the primary consumers. So those that are really depending on algae, and we can argue that a little bit because these organisms obviously are some in a way omnivorous in a sense. So what I'm showing you here is a food web, a simplified food web of those systems that had tapples in them. There's my little tapple on the bottom. At the very top, I'm showing you my main insect bracers. So this is from left to right. This is a water penny beetle, a moth larvae, and 2 families of mayflies. The numbers, and I don't want you to worry about the numbers, but just to explain the figure itself, are really measuring secondary production, consumer production, right, over a unit of area over time. So we think a lot about primary productivity, right? The growth of plant tissue over time. This is doing the same. This is now thinking about the growth of animal tissue over time and over a unit of space. To be able to know that, right, you're accounting for things like abundance, biomass, growth rates, their success, I mean, all these things. So it's a measure perhaps of the success of an organism in a system by really growing tissue that now becomes available to other trophic levels. So why am I interested in something like that? If we go back to my initial picture, well, this would eventually be the food for fish, right? Or the food for other consumers. So it's important to know how much energy or how much mass I'm building from one system to the next, or one compartment to the next. And I'm doing this in a rate type of view, right? So I'm not doing this in terms of how much mass is there at a given time, but really how much mass or ash-free dry mass is generated over a unit area over time. So this is a dynamic measure, which is similar to the way that we measure primary production. Based on that information, I can use the ecological efficiencies of those organisms and understand how much energy they need to consume to be able to generate that production. So these arrows and the numbers are really reflecting how much consumption of that resource is needed to generate that number at the top. And very quickly, and I know I said it already a couple of times, I don't want you to worry about the numbers, but if you add this up, it's more than what you have here in terms of grams. So you could quickly assume that this is a system where those consumers will be food limited and will need to rely on other resources. Not only that, but this is the amount of primary production that is available when tapples are there, and what they're already consuming is taken out of that. So what happens? If I look at the systems without tapples, I already show you visually that the system look different. Some accrual of mass, right? And just those rocks look a little bit differently. The first thing that I notice, and perhaps like the easiest thing to notice, is that the resource base or the algae, the primary production, had increased at least over 5 times what you had before, because now You don't have that bulldozer keeping the algae down, but it's also different. You shift it from somewhat a diatom base, perhaps like just smaller, quick growing primary producer base, to now more filamentous algae that will senesce and become somewhat, that brown kind of accrual that you saw initially. So that's the first thing, and I have the tadpole out. So what does that mean to other grazers? Does it mean that now my other grazers are benefiting by not having to compete with the tadpole? Well, obviously, by seeing how the system changed, it didn't seem to indicate that this invertebrates or this grazers will compensate for the loss of the tadpole because now I have more mass than what I had before. But what we also notice is that some populations or some particular taxa really were decimated or impacted negatively by the loss of the tadpole, where they reduced their production, their abundance of biomass by over 50% or close to 50%. Meaning that now the tadpole, even though it was a competitor, they're also facilitating a resource base, right, that allowed those organisms to be successful. And over time, the concern is whether that resource change will completely eliminate them. Whereas other organisms, like the mayfly families that I'm showing here, just to be general, they did benefit from the removal of the tadpole, where their production increased, and now their amount of abundance and biomass was increased. And we can take this picture beyond that those organisms, particularly mayflies, will have aerial adults. So if you have more production of them, there's the likeliness of those exports going into terrestrial system being increased as well. And that might impact now the food web at the terrestrial zone, particularly for those organisms that would feed on aerial insects. Now, I'll show you the picture. Frogs were feeding on aerial insects. Well, they're not going to be there anymore. So what other organisms now capture or try to change or compensate for the loss of frogs in the terrestrial zone as well? So this is a good example of how we could use benthic invertebrates to understand how resource change might change the composition of an ecosystem. So one where you're removing a consumer entirely. I'll give you another example. This is from work I did in Puerto Rico. This is the Luquillo LTR. This is a site that is a part of the NSF's long-term ecological research network. If you think, sites around here like Coweta, sites where I am in Southeast Georgia, Sapporo Island, many sites across the globe doing long-term research with similar missions in mind to try to understand how ecosystems work at different biomes. Now, the neat thing about this, if you're not familiar with Puerto Rico, an island in the Caribbean, the site is in the northeast of the island. But if you look at I know this is just a drawing, but the national forest, and this is kind of the U.S. national rainforest technically, is really an island within the island. This is just a drawing, trust me, just from the greenness. But if you look at a picture, a satellite picture, you really see that patch of rainforest really surrounded by a lot of development and technically shrinking over time. If you're not familiar with Puerto Rico, a lot of Puerto Ricans, very overpopulated, and a lot of change, like in many other tropical parts of the world, right? Where you have a lot of development happening very quickly and potential loss for habitat, loss for, in the tropics, we think about loss for forests, the need for harvesting products and things like that. In Puerto Rico, more so as an aquatic ecologist, let me go back one. No. In Puerto Rico, more so, Puerto Rico has a central mountain region where most streams originate from there, and they very quickly, in a short distance, are going from freshwater down to the ocean. So the need for freshwater in a rapidly growing population means there's just a lot of demand. So Puerto Rico, for a U.S. territory, is the heaviest dammed territory in the U.S. So the amount of dams, whether it's large hydroelectric dams or water retention structures, is very large per unit area. So that makes it challenging to try to understand water resources, particularly when you have a national rainforest. The good news is that because of the LDR system, we know a lot about the consumers and the food webs of these ecosystems, and particularly in streams that don't have fish, whether it's because of natural barriers or because of dams. Macro consumers tend to dominate the food webs. Shrimps and crabs are shrimps are very diverse. Crabs, they're not as diverse, but also play a huge role in terms of moving energy from aquatic systems to terrestrial systems. And, in the culture of the island, also a potential food base, right, for humans. Now, they also play an important role in the diversity of functions within the system. So shrimp in particular, they are very functionally diverse in the way that they process resources. Some of them specialize on suspended particles, septon, floating downstream. Some of them really facilitate the composition of organic matter, particularly when you have tropical forests and you're depositing a lot of leaf litter throughout the year, right, into streams. And then some of them even specialize on grazing periphyton and algae, so providing a top-down control very similar to what we saw for tadpoles. In fact, some of them will do all those things at once. This is a picture, and there's great videos about this. If you're familiar with Freshwater Illustrated, this is a great source for media, and they have short documentaries. They've done a great video to illustrate the importance of freshwater shrimp in Puerto Rico. What you're seeing here is an Atia shrimp, and those brushes or those extremities are a tool for them to not just graze on rocks, kind of like wax on, wax off kind of movement, and bring periphyton into their mouth. But also what this was doing out here is just open them up as fans, and as particles are being exported downstream, they're capturing those. So they're not only, if you're into feeding ecology, not only grazing on algae, but they're also filter feeding, almost like a bivalve will be doing, right? So very interesting. Some of them get very, very large, and as you can imagine, they also play a role as predators. I don't want you to worry about the numbers too much, but the good news is that because it's an LTR, there's been a lot of work on shrimp there for over 30 years now. So there's been people out there measuring populations of shrimp and seeing their changes and seeing how they're impacted as you lose habitat. I was fortunate enough to work with one of my students to do the same kind of tools or mechanisms or projects as we did in Panama, where we measured the production and the food web connection of benthic invertebrates in relation to streams that did not have fish, but primarily shrimp as the major macro consumer. And what I'm trying to show you out here, same scenario, the width of the arrows really represents how much energy is being transferred from basal resources all the way to this middle stage consumer. And what we found there is that a lot of these categories out here, the larger arrows are coming from detritus, plant detritus, amorphous detritus, it's just detritus that we don't know what it is, but we know it's just breaking down material plants. And even fungi, which is fungi that colonizes plants as they're decomposing. So the primary microbe that is out there, hyphomycetes, are colonizing the leaves and facilitating the decomposition process. So what this means is that this middle level consumers, which will be the important food base or the conduit for energy to higher trophic levels, are mainly dependent on plant material from outside the system. Why is that important? Well, let's go back. Tropics. Habitat loss, deforestation. Big problem if you think about how your middle consumer conduit of energy is depending on that energy source. So this is neat, and this is work that, not new in sense of using using secondary production to construct quantitative food webs, but we've been doing this for decades actually in streams in this area towards the Appalachians, but not necessarily very common, or not a lot of studies of production in quantitative food webs in the tropics. So having the opportunity to recreate this very traditional and somewhat common processes and common studies from temperate zone into tropical systems will help inform what the potential loss of habitat, potential loss of consumers, potential loss of diversity might be in places where we might not have that information yet. So yeah, so this is exciting. This is one where you see all those question marks. That's me trying to tell you as students, come work for me and fill in the gaps, right? Can't be that bad. Go to Puerto Rico in the summer or something. That's gotta be horrible, right? But I am doing where I reside, and most of my work is in Southeast Georgia, where I'm at Georgia Southern University, which is right around here. Coastal plain rivers, coastal plain streams, technically in the same premise, an area of the US where you're getting rapid population growth and rapid development of areas that in a sense, we're turning over relatively natural habitats into more developed and more industrialized areas. Let's just call it that. So one of the neat things about the work that I'm doing out there, if you're familiar with the coastal plain, the system I'm highlighting here is the Ogeechee River. The Ogeechee River in Southeast Georgia is a river that is almost entirely in the coastal plain. Meaning that as you get to the fall line, it's got several tributaries out there, but the vast majority of it, what I'm painting out here, is in the coastal plain. It is one of the few rivers in the US that is entirely undammed. Think about that. One of the few rivers in the entire US that does not have any hydrological alteration due to dams, meaning that this river, in a sense, is functioning the same way that it would have, hundreds of years ago. Which is neat to have that river in your backyard. It's a nice source to study not just the background and the function of this type of rivers, but ideally to use that as a premise of like, please, this is how this river should function, relatively different than when I drove from Southeast Georgia to here, the Savannah River, right? Which has at least three, I think, major dams, right? And even the Altamaha River, which actually, the Altamaha River is actually a very gem of a river as well, but it also depends on two major rivers, the Oconee and the Ocmulgee, that go towards the Atlanta area. So again, a lot of potential for human impact there, even though the Altamaha, beautiful river, another river that we work with. So just to kind of continue to the approach in some of the scenarios that I painted before, what my students do there is we use a continuum approach. If you're familiar with the river continuum concept, to just predictably see how rivers change from the headwaters all the way down to the coast, but also using a food web approach. So my students have studied food webs in areas towards the headwaters of the river and all the way down to the coast. This is a connectance food web, so not quantitative. We're just using dots to connect linkages or nodes, right? Where the consumers are on the top. So think about a food pyramid and your resources at the bottom. What I'm trying to show out here is that in terms of just spatial spread, right, over space from the headwaters down to the coast, you do see a change in the complexity, right, and the amount of linkages that you might expect to have in those areas. And out here, for this particular picture, I'm not just focusing on invertebrates. There are students that work on fish in this area. If I think about this over time, this is one site, kind of mid-river. And what I'm going to show you is real quick, same thing, food web, resources at the bottom, consumer compartments at the top. But if we think across the year, this is in spring, summer, fall, winter, we do see that those food webs, even over time, right, are shifting, or the contribution from particular consumers is different as you go across the year. And that makes sense, right? Seasons of the year, coastal plain river, undammed, flood poles is a big component of just the predictable nature of those rivers, but also again, the temperature, resources, whatever they're relying on, are also going to change. So this is another great system to really understand the role of consumers in ecosystem function. And I encourage you, if you're interested in this type of work, to come help me out, draw numbers into those arrows by measuring and quantifying not just the production of consumers, but also the production of resources. All right. Woo, that was talk number one. How am I doing? Good?
Good. 11:48.
Okay.
Have about another little less than that.
Okay, perfect. So that traditional research, I mean, that's what I'm interested in. That's been the makeup of my career, and I feel incredibly fortunate, right, to have an academic career where I get to do this. I mean, I was talking to students yesterday in Troy. I mean, we mentioned best job in the world, right? To be able to do research, play in the water, flip rocks, like look at invertebrates. I couldn't change it for the world. And if you couple on top of that, the opportunity to come to places like this, travel, talk to students, teach class, mentor, there's no better job in the world. So I feel very fortunate. And in fact, I started my presentation talking about like how, for me, diversity was my hook. I, as an undergrad, had my first few samples and started looking at bugs and said, like, man, this is from outer space. Yes, I want to do this. And I don't see myself working with anything else. And hopefully I gave you the pitch as to why diversity in this consumer communities, for me, working in the water, right? But if you're a terrestrial ecologist, terrestrial biologist, yeah, the same, right? Diversity is probably one of the drivers of the type of work that we do. And in the Southeast, where we're in a hot spot of biological diversity, even better. But here's the thing. Throughout my career as an aquatic ecologist, I found that this was the driver in diversity above the water was not necessarily the picture that I thought I wanted to paint to my students when I wanted to convince them to have a career in science. And I didn't find, I mean, naive as I was, I had a very traditional upbringing or pathway to my career in science, and I'll talk about it in a little bit, but yes, an undergrad, I had research experiences, I had great mentors, went to graduate school, got to travel a lot, and then went through the traditional pathway to an academic position. Naive enough not to think that me being here talking to you, that's very rare. That is incredibly rare, and I'll show you. My master's is in fisheries. I went to LSU and the other Tigers. You'll beat them a lot, so I don't feel bad. But when I finished my master's, for those of you that are master's students, and everybody that I've met to, I asked them, like, what are you doing after you finish your degree? When I finished my master's, I thought, it's like, well, I was in fisheries. I'll definitely get a job with like the DNR, the Fish and Wildlife, something like that, right? I'm going to be a fisheries biologist. This is work from two colleagues, Ivana Arizmendi and Brooke Penaluna, in 2016, surveying not just looking at the population of the US, those are the bars at the very top, and the makeup demographically of the US population, coupling that with national data for the population of folks that are participating or earning PhDs, right? And then try to couple that with careers in fisheries science. So when I was a master's, I was like, yeah, fisheries biologist, that's me, I'm gonna be there, right? Not good for me. Not a lot of people like me getting jobs in fisheries science. And I was naive, I mean, I wouldn't just rail right through that. Well, I went to get a PhD, okay, well, how about a career in academia? From the assistant to the associate to the full professor, I'm an associate dean, so imagine how that bar looks. Even worse. In the population of the US, even though this is a survey from 2010 and 2020, the numbers haven't dramatically changed, particularly if you think about the number of underrepresented minorities, Hispanics, Blacks, Latinos, Hispanics, African American, Blacks, Native Americans, that are not just pursuing careers, but really getting the preparation to go for careers, that they're not necessarily painting the picture in terms of the profession. I'll go a little bit beyond. If we think about the classroom, right? Because this is what I do as an academic, is to try to think about, right, the population of the US, the population of my students, very similar, particularly teaching in the Southeast in Georgia, right? Or here's the population of my colleagues. Did I say that I feel pretty fortunate to be here? Yeah, it is rare for me to see myself in a position like this. And I didn't think about this as a graduate student. I didn't think about it as a brand new assistant professor. I got to think about it a little bit more now when I see the makeup, when I'm in a position where I get to at least contribute to the decisions of my colleagues, the workforce, the people that are providing now mentoring for students. And because of that, I've shifted a lot of my work, and I'm not saying that I'm still not psyched about diversity and working with insects. I'm doing that every day, but I shifted some of my work in my scholarship towards resources for broadening participation. And this is the terminology that I'll use, is the common terminology when you look for this type of support. But why broadening participation and what it means to broaden participation is simple enough. It's just making sure that we are bringing, right, as many people from all kinds of backgrounds, fields, experience, all that into the training that leads to the workforce, right? Why? The same way that I argue that biodiversity is important beneath the water and the ecosystems that I study, I have to argue that that's going to be very important when it comes to decision making, when it comes to providing resources, providing data, and really supporting those resources for the populations that are going to need it, which is us, right? My kids, your kids, so on and so on. So I'll use that framework. And as I continue to advance in my career, I started shifting some of my funding decisions, or my pursuit of funding, to opportunities to do that. And the question was like, well, what worked? What worked for me that allowed me to persist and become, one of the few represented minorities in my type of work? Well, again, my pathway was not very different than most of the faculty, most of my colleagues, which is great. I got some of my first experiences as an undergraduate intern for a program, the flagship internship program funded by the National Science Foundation called the Research Experiences for Undergraduates, or REU program. So when I was an undergraduate, Aaron mentioned I went to the University of Texas at El Paso, a minority serving institution, and I had the opportunity, being too far to go back home in the summer, to apply and have a chance at an REU position. Took me to Manhattan, Kansas, a place that I would have never imagined I would have gone, but I got exposure there to the LTER system, the long-term ecological research site system, by working at Concept Prairie, one of at the time, I think it was about 28 LTER sites. And there I am, just getting hands-on experience, working in rivers. This is Kings Creek and Prairie Stream, and actually this is when I started getting exposure into invertebrates. Those little boxes that I was doing out there were chironomid hotels, where I would put chironomids, Mitch flies as larval immatures, and watch them grow and collect them back and then measure their growth and understand how secondary production works, which is super neat. The good thing about that is that led me to really think about, research, I could do that from start to finish. I was fortunate that I primarily worked with groups, collaborative groups that were incredibly diverse. This is Matt Wiles. He was my mentor as an undergraduate and also became my mentor as a PhD at Southern Illinois University. But the entire research team, this is for the work I did with amphibian declines, was very diverse, right? There were people from all kinds of backgrounds, demographics, all this, and it taught us how to really kind of be very collaborative. The key about that is that when I finished my undergrad, I thought like, graduate school, fisheries biologist, I'll do that. This is the pathway. But as I finished my master's, I didn't think I was PhD material. I was like, there's no way, man. This is people that are going to like Ivy Leagues and things like that. Well, it turned out that part of that was my insecurities were based on English wasn't my second language, right? I went to UT El Paso. That didn't sound to me like a school where you're kind of harvesting PhDs, although I didn't know. Great school, lots of great PhDs out there. But I didn't think I was competitive enough for these positions. Those were the same things that made me competitive. I went to work in Panama. I spoke Spanish, perfect, first language, right? I had gone to a school where I was working side by side with other Latinos and minorities and working already in diverse groups. And now at this point, I already had a master's that gave me exposure to federal funding in a different way, the U.S. Fish and Wildlife. I worked for a co-op. So I had a background that was diverse enough to really solidify my ability to do this work. And it was great. And then perhaps the third component of that is that I had, and I mentioned before, great mentors that provided me with all the resources that I needed and never looked past the fact that, there's not a lot of people that look like you in the profession, so maybe you should think something else. They never did that. They actually provided representation. This is Alonso Ramirez, another Hispanic, who was my postdoc advisor. He's a professor at North Carolina State. And he actually made me feel like, hey, there's a job here for you. And it didn't matter, right? Where they were from, their background. So like that base, that strong foundation allowed me to be naive enough to continue to get exposure to funding sources, research collaborations, diverse groups that later on, not knowingly, played an influence in the type of mentor that I wanted to be, in the type of programs that I wanted to build. So that was great. Obviously, the RU was significant enough for me that when I got to Georgia Southern, I spent a lot of time trying to make sure that I got an REU program funded. So if you're an undergrad here and still have undergrad time left next fall, I do encourage you to look into REUs for next summer. Wink, wink, look at mine. Yeah, absolutely. Love to see your name in there. But the goal of this is really getting a cohort base of undergraduates to give them experience and exposure to the research process and hopefully improve their chances at graduate school, career, so on and so on. and with the premise that the NSF, one of their missions for their funding is broadening participation. And broadening participation means a lot of things. I don't want you to think it's like, well, maybe I'm not a minority. Well, think about just what makes you unique, whether you are going to school in the Southeast and now you need to get experience in another ecosystem. Whether you went to a primarily undergraduate institution, whether now you have resources in one field and you want to get resources and experience in another field. That all goes into the merit of what this program builds. And now, more importantly, because we all went through a pandemic that took out a lot of opportunities, not just in terms of hands-on research, but a lot of opportunities for several years in a row for undergraduates. The NSF has now invested in a mentoring for postbac program. This is the RAMP Research and Mentoring for Postbaccalaureates, students taking a gap year that could use that gap year almost as a pre-graduate school experience. And the best thing about these two programs is that you get paid. You get paid to get this experience. And you get to work with faculty on research, you get exposure, and ideally, and you get paid well too. So, and ideally, this allows you to see whether this is a career path that I want to pursue. It was for me, and probably by far the most meaningful experience, having that hands-on experience with faculty members that later on became my mentors. So I do encourage you to look at those. The REU has over 127 sites in biology alone, each one of them for undergrads, each one of them, they fund between 8 to 10 students in a cohort for 10 weeks of summer. The RAMP, which is new, also cohort-based, 10 students for a year. So if you graduated, let's say you graduated this December, this May, there are now, this year was the first batch of RAMP sites. There are about like 12 to 15 sites. Next year, about another 12 to 15, including one in Georgia Southern will start. So I encourage you, not just you if you're here, but if you're a graduate student in UTA and you meet with undergrads, tell them about this program. If you're a faculty member, tell them about this program because it's a good incentive to get that hands-on experience and exposure in the research process that ideally leads to opportunities in graduate school or leads to opportunities in another thing, and yeah, I'll tell you about the one thing with our programs, just to pitch them a little bit. We are in the coastal plain, so one of the things that these programs are doing is really exposing you to the resources of the coastal plain. And not just go out there, see the sites. If you haven't been to the Okefenokee Swamp, a fantastic site, but really show you the needs in terms of opportunities, careers, like the type of agencies or so, and this is a wildlife refuge. So the type of agencies and the type of jobs that are available at those sites. What type of careers you might expect to have at those sites. Because that was something that worked for me. When I was a master's student, I worked in a U.S. Fish and Wildlife Co-op, so it exposed me to the actual career that I was thinking about having. Also doing good things while you're at it. So we collaborate. This is a collaboration with the South Carolina DNR, where we are using this is the recycling oysters program to build or to help with potential erosion and build oyster reefs. This is a great program out here. They do look for volunteers all the time. So if you're from South Carolina, close to the coast, definitely look at the program from the DNR. But if you have an opportunity to participate in an RU or in a RAMP, we'll be doing that, not as a volunteer experience. We're going to pay you a lot of money to do to get that exposure to. That was great. I think, definitely geared towards exposure to the profession. And there are several venues for that. I don't want to just pitch NSF because NSF, again, it's just one type of funding, that again might have just limitations for folks in terms of what you want to do, where you want to go. There are programs like this all throughout the U.S. There are programs like this that might already be in your institution. I failed to check, but things like the LSAM, the Louis Stokes Alliances for Minority Participation, or the McNair program, those are programs that tend to be at institutions. So if you do have a program like this, definitely encourage the faculty and even the graduate students to see if there's the potential for you to mentor a student or the potential for you to get involved, or as you go towards your career, look for those type of programs. And there are great websites like the Institute for Broadening Participation or Pathways to Science where you can advertise opportunities or recruit students to join your programs, find out about your programs. So, and of course, the RU and the ramp, big programs, and I wanted to pitch mine, so definitely want to put them in there. Going to conferences was by far one of the most rewarding things that I still get to do as a scientist. I mean, I met Aaron at a conference, and I think we sometimes miss the mark as to the power that conferences could have. Having your students go to conference, current to a conference, and that's great. And I'm not saying we miss an opportunity as faculty in taking students, but us as scientists sometimes miss an opportunity at really portraying what the scientific community is like and what it should be like, right? What potential opportunities are there? And I'm not saying just for careers, but feeling a sense of belonging and representation in your scientific society. So I want to highlight two conferences here, particularly SACNAS, the Society for the Advancement of Chicanos and Hispanics and Native Americans in Science. It is kind of just leaning there to just Chicano Hispanics, but no, this is the National Diversity in STEM Conference. If you're not familiar with it, definitely look into it. And then this tends to be more Southwest focus or active, whereas manners, minorities in agriculture, natural resource, and related sciences tends to meet a little bit more in the Southeast or the East Coast. Look at both of these conferences as a potential venue for highlighting your programs, for recruiting students, for really bringing now that underrepresented minority representation into your program. And if you're an aquatic scientist, which I am, I'll tell you about an effort that 9 aquatic scientific societies are already invested in. So it's great if you could go to the conference, but if you can't go to the conference, that's fine. You know, I'm going to the conference and I'll pitch and promote your program so that you could get students, professionals, whatever you need in terms of really broadening the participation of your field at your institution, your program, your society. This is through the Consortium of Aquatic Scientific Societies, where we've been out there with an exhibit booth for the last 8 years, pitching or promoting this scientific societies, hopefully some scientific societies that you know already about and that you might even belong to, right? And I don't want to just say that this is an aquatic science scientific society thing. I mean, these are things that the ESA has been doing for years with their SEEDS program, and many other societies have invested on broadening participation through recruitment. How am I doing there, Aaron?
You got 8 minutes.
8 minutes. 8 minutes is this all I need to pitch this. All right. So scientific societies. I was fortunate enough. Aaron mentioned this a little bit. When I started my academic career, the scientific society that I call my home, the Society for Freshwater Science, gave me a platform to provide travel fellowships to students to come to the conference. And we started that. I started at Georgia Southern in 2010. In 2011, I brought my first cohort of 6 students from other universities to come to a scientific society meeting, fully funded, full ride. Over the last 12, now 13 years or so, we funded more than 160 undergraduates through this InSTARS program to come to societies, to society meetings. And I'm not just saying like, yes, we went to like Jacksonville and, and whatever, like Columbia. We went to Brisbane, Australia last year. Full ride for undergrads to really get a sense of what the scientific conference and what that venue might be like. I'm pitching, obviously, the one from my society. There are many programs like this to provide that opportunity and that experience, right? This program, the success of this program, catapulted a little bit to where the National Science Foundation provided us funding for 5 years to now not only bring students to the conference and not only bring undergrads, but also graduate students and early career professionals, postdocs, people in early career positions, to not only be part of the society, but also participate in training, build cores, build communities, have a year-round mentoring program built around National Science Foundation funding. I'm just going to go through it very quickly, but what we do is we connect activities that are built on social psychological factors to ideally lead to scientific integration and persistence in the field. So we're doing all these activities that hopefully mean that those numbers that we saw initially in the profession shift a little bit more where we're preparing students and professionals, given the currency to stay in the field and stay in the profession. How do we do this? Well, before the conference, we'll go on a paddle trip and do a river floating where you get exposed to resources of a particular site. We started doing this in Grand Rapids. I know AFS went to Grand Rapids this year. Several years ago, we did a float of the Permar kit out there in Michigan. You go to the meeting, right? So that's great. The meeting is already a catalyst. That's like scientists on spring break. I mean, it doesn't get any better like that. Then we couple this throughout the year with workshops for professional development, skill development. So we do 2 workshops. We partner with NEON, the National Ecological Observatory Network, to provide a workshop on data analysis using R. And then that's in the fall. That's actually happening next week for our cohort, our current cohort. And then we do one on visual communications that is technically graphic design and presentations on an open framework platform. So how to develop posters and presentations and build those skills. And the thing is that because we are funding students from different universities, in fact, I had 2 Clemson students last cohort. They are flying those students to NEON sites, to LDR sites, and sites like that to work with colleagues from other universities and hopefully have that as an expansion of their network. So that's a great program. And then throughout the year, they build community. We use a program called Gather Town. It's hilarious. This is great. You kind of your little avatar, and they do a lot of interaction. In fact, I think there's even a game room. It might be the things upstairs, where they just kind of have a space for them to chat and communicate with their friends and other universities and talk about cohort building to potentially provide that platform to persist in your career. And I think that's, I know I'm close to time, so I'll just pitch the fact that our application will open in November for our 4th cohort that will start next June with the Society for Freshwater Science Conference in Philadelphia, meaning that group will come to Philadelphia, they'll do a paddle trip, they'll go to the conference, and then we'll kick them off from there. So I'll stop at that. I think
we have about 4 more minutes.
Okay, perfect. But yeah, thank you all for having me. I really appreciate the opportunity, and hopefully I got a chance to answer questions. Thank you.
I'll also look online for questions if anybody has any online.
Questions? That's the one. Yes.
You didn't go into the details of how your community switches in the Ogeechee, right? That's where you were.
Yeah.
And so how does it along the continuum?
Well, so there's a couple of things that we're trying to untangle there. So there's already a predictable, right, that the river continuum concept already gives you a framework for how you expect diversity to increase at middle reaches, because you have now not just the resources, but the habitat complexity from upstream and then a little bit from downstream. So it becomes an ecotone. Our concern there is the amount of development that we might have where you have that ecotone. So we're right now experiencing the development of a large Hyundai meta plant in close to the watershed where you would have those more diverse sites. Now, thankfully, that group has been very engaging with some of our conservation and management stakeholders. So they've really been at the forefront of make sure that we're not, we're monitoring this or supporting projects to be able to see that. So what we want is that shift to not find some sort of a roadblock, right? Before you get to downstream, where now you lose that ecotone that is now harvesting diversity for the upstream, but also for the downstream. But this is very early. We're right now building the baseline data sets by just finding out what's there. And we've had issues before. Fish kills recently sprouted some of the funding to get some of this work started. We're fortunate enough that in the 80s, there was a lot of work done in the Ogeechee River on macroinvertebrate production, microinvertebrate community. So there's a very rich database or data set of what the communities look like there 30, 40 years ago. So now we're kind of coming back to the picture and seeing where we're at now, and hopefully maintain that so that we don't have an impact moving down later as the area continues to develop. Yeah.
Maybe another quick question before we finish up.
Yes, so
I was wondering what your lab looks like in terms of diversity and like, do you have to search or seek out that diversity, or does it seem like those are the students that just contact you?
That's great question. I mean, I purposely recruit in this venues for that. Now, I'll be lying if I didn't say that having these programs have become a hub for me and for my colleagues to be able to train students and bring them along the lines that eventually become our graduate students. And right now that I am a little bit removed from a connection with the undergraduate population at Georgia Southern, I have to be more purposeful as far as looking or pitching opportunities specifically for underrepresented students. And here's the thing, sometimes you will have barriers in terms of how to do that, right? So and it's important for me to go beyond those barriers. And a barrier might be, you can't advertise, or you can't, the things are coming. You can't put a note out there that says, I encourage minority students to apply. We've got to push back for that. And it's not that I discourage other students from applying, but having that out there, I want to make sure that message is getting across so that, hey, yeah, we want you to come in here. But it cannot just be one way or the other. I mean, the students in my lab are fortunate enough that they're coming in from either word of mouth or what they've seen in classes. So I try to maintain a dynamic where we do have as much of a rainbow as possible of a lab community. Yeah.
Right, well, that finishes us up, and right at 12:16, so let's give Checo a round of applause. Question in the meeting chat, Dr. Checo can.
Yeah, I can type it there, yes.
Everybody else can. As far as
Yes, yeah.
and for folks that are staying for the lunch, we have. It's.
That was,
I'm not getting.
Yeah.
but at the same time, different, not like.
Yeah.
It's right from that.
Yeah. And now you're-
Yeah.